Our next exercise considers the following function. This function is called decreasing marginal utility function, and its explanation is rather simple. It's drawn up here, and let's say that on x-axis we have ice cream. We buy one ice cream and we eat it. We buy the second ice cream and we eat it. We buy the third ice cream and we eat it. We buy the fourth ice cream and we eat it. The more ice cream we buy, every next ice cream will taste less and less good. That's because our stomach is full. And this is the basic idea behind decreasing marginal utility. Every new ice cream will be less good. It will still be good in a sense, at least the second or third, but it will not be as good as the first one. Okay, of course this is a concept that is actually very applicable in business as well. It's not just about eating ice cream. For instance, let's say that you have a situation where you produce 4 kinds of clothes. You have some kind of an amount of material and you have a number of people on staff working. And now let's say that you have too little material, and your problem is to find which products to produce exactly, when you will want to sell them for as high a price as possible. And if you have too small of an amount of material, you basically tend to do things, I mean, if you have like shirts or short trousers, you tend to do things like short trousers where there's big need for workers, but a small need for material, comparatively, of course. Now, let's imagine that we have more material now. We add more and more and more material, and actually this is where once again decreasing marginal utility comes into play. It means that every time you add more and more material, your profits will increase, because in the beginning you had too little material, you produced too many, let's say, short trousers, but the profit will be increasing more and more slowly. So it's safe to say that everywhere in economics you will face the decreasing marginal utility. And now our goal is to draw the graph here. Okay, let's do it like this. Let's select these 8 cells and let's click on formulas, create from selection, and left column. It takes the names from the left column, and this will, for instance, be called start, so it works nicely. Let's choose x's and y's, and up till the until the 37th row. So that's what we want to choose now. Let's do once again formulas, create from selection, top row, and here it is. The only the cells, let's take y this time. The cells up till 37 together are called y. So it works just fine again. Now let's build again our table. Once again, just like all the tables of today, it's going to be progressing, this time from up to down. Let's write the first value. We want to just make the x-axis progress again, so the start is at 0, equals start. The second formula is the same the second formula is the one we're going to copy all over the table, so it equals the last value equals B11 plus step. So we are always adding one step to it, and we're going to copy it until the 37th row, and it will progress from 0 to 130. Okay, Now let's try to get this formula done. It's a mathematical one, but we want to draw this curve, so we have to enter equals a times, and we're going to see the reasoning behind this formula, or what a means and so forth, just in a second. Equals, let's just at the moment let's just type the formula in, equals a times parenthesis 1 minus e sorry, now e is exponent, which equals 2,71, and with p, the case was often that p was used in its original form, 3.14, but e, 2,71, is often taken to the power, to some kind of power. That's why the function here is called x, but it takes into parentheses to which power we want to put e. So what we effectively will need to do here is to write x parentheses minus b times x. So now we're using the exact formula from above. Now let's close the x parentheses. E has been taken to the power of minus b times x. Now let's close the other parentheses, and we will have the formula working. Let's copy this formula, and it always takes out the corresponding x value. As you see, x is in purple here, and it takes this x value out. Other things, b and a, come from upper part, which controls the whole table. Okay, now let me just show from the last exercise that if we wanted to take this quadratic function, and let's say that the start is minus 55 and the step is 33, and here you see a different part of the function is drawn out. So just to recapitalize that this upper part controls the entire table. Now we want to draw the next table. We want to select it all and choose insert, and once again scatter graph, because we have coordinates for both x and y axis, and here it is. This is the decreasing marginal utility curve. Once again, let's delete the double y headings here. And what we see when we, of course, such formulas can be interpreted all the way. But one of the things that sticks out right away is that a, this 90, seems to be the value, that is the, mathematically again, to throw a term at you, is the limit to the utility function. So in other words, this utility always gets nearer and nearer to 90, but it never actually reaches 90. So that's how this curve is drawn. This is just the nature of how this formula works. And we could describe the whole formula here. For instance, if x is 0, then here we got a 0. E is to the power 0, which is always everything to the power 0 is 1. 1 minus 1 is 0, which means that if x is 0, the whole formula will be 0. If x is very big, let's say 100, then e is taken to the power minus, let's say 100. To the power minus 100 is, in other words, 1 divided by e to the power 100. This means that the number is going to be very small, which means that 1 minus very small number is almost 1, which means that everything gets nearer and nearer to a. That's how this formula works. You can always try to figure out the formulas this way. And we effectively have the decreasing marginal utility curve depicted. But we'll have more curves today.